Hello students, how are you? Now we are going to discuss about chapter 1. Chapter 1 mainly deals about how to find domain and range of a function. There are different kind of functions that we have already learned on the lower class or on the upper class, and we will start from the first polynomial function. Polynomial function is any type of function that can be written in the form of f of x is equals to an x raised to n plus an minus 1 x raised to n minus 1 plus an minus 2 x raised to n minus 2 up to x raised to 0. Any type of function that can be written in this form is called polynomial function. So there are different kind of polynomial function, and we have to make remark. And for any polynomial function, its domain will be always real number. You have to use this, but range may or may not be. Range may not or may be real number. No problem, we will talk a lot about this. So the first example now we are going to discuss is the first types of polynomial function is what we call 0 degree or constant function. It has a general formula of f of x is equals to k. Example, f of x is equals to 3. When you graph this in the xy coordinate, it will look like this. This is x, this is y. Let's say this is 3. Its graph look like this. Whenever you cross a horizontal line, you'll cross the line. So its domain will be x, an element of real number, and its range will be equals to 3, because whenever you don't get the graph, you only get the graph when y is equals to 3. Therefore this is what we call range. Example 2, f of x is equals to 2 minus 2. When you graph this in the xy coordinate, it will look like this. This is x, this is y. Therefore when you graph, let's say this is minus 2, this is the graph of f of x is equals to negative 2. Whenever you draw, you will cross the given equation. So its domain will be x, an element of real number, and y will be equals to, whenever you draw a horizontal line, you will only cross the line when y is equals to negative 2. So this is called range. The third example will be, example 3 will be f of x is equals to 0. When you draw this, it will look like this is x, this is our equation, and its graph, whenever you draw a vertical line, it always cross the equation. So its domain will be x, an element of real number, and its range will be x, y is equals to 0. Whenever you draw a vertical line, you will cross the point when y is equals to 0. So this is the first type of equation, the first type of polynomial function. And the second type will be first degree or linear function. This type of function can be written as first degree or linear function. This type of equation, it have a general formula of f of x is equals to ax plus b. Why we say it's first degree? Because its highest exponent is from x and x raised to 0, the highest is 1. Therefore it is first degree or linear function. For example, example 1, f of x is equals to 3x plus 2. Whenever you draw this, it look like this. The graph means. So whenever you draw a horizontal line, a vertical line, it always cross the equation. So its domain will be x, an element of real number, and its range will be, whenever you draw a horizontal line, it always cross the given equation. So y will be an element of a real number. The second example, example 2, will be f of x is equals to minus 3x plus 2. Whenever you draw this in the xy coordinate, it will look like this. This is our equation. This is x coordinate and this is y coordinate. Whenever you draw a horizontal line, it always cross a vertical line, it always cross the equation. So its domain will be x, an element of a real number, and its range will be, whenever you draw a vertical line, it always cross our equation. So its domain will be, its range will be, y is an element of a real number. So the third type of polynomial function is called second degree, or what we call quadratic function. This type of function have a general formula of f of x is equals to ax square plus bx plus c. Therefore, our highest degree is from 2, from 1, and from x raised to 0, the highest degree is 2. Therefore, it is second degree or quadratic equation. So its domain, x is an element of real number. Why I say it is x is an element? Because for any polynomial function, domain will be always an element of a real number, but range depend on two factors. The first one is on the coefficient of A and the y coordinate of the vertex So how can we find coordinate of the vertex? We have the general formula. Let's say x, y, b, coordinate of the vector, coordinate of the vertex. So in order to find x have a general formula of minus b over 2a, and y have a general formula of f of minus b over 2a. So therefore coordinate of the vertex will be minus b over 2a and f of minus b over 2a. Example, f of x is equals to 6 plus 5x plus x squared. First, we have to check whether the function is second degree or quadratic equation. So first we have to rearrange. The highest degree must be written from x raised to 0, from 1, and from x squared. The highest degree is x squared. Therefore, f of x can be written as x squared plus 5x plus 6. So we have, in order to find its vertex, its x coordinate can be calculated like minus b over 2a. That means minus 5 over 2 times of 1. This is equals to minus 5 over 2. And its y coordinate, y is equals to f of minus b over 2a, or f of minus 5 over 2. So our given equation is x squared plus 5x plus 6. So in terms of x, we will insert minus 5 over 2. Minus 5 over 2 the whole square plus 5 times minus 5 over 2 plus 6. Therefore, minus 5 over 2 the whole square will be 25 over 4 minus 25 over 2 plus 6. So we have to take 4 common. When we take 4, 4 divided by 4, 1. 1 times 25, 25. Minus 4 divided by 2, 2. 2 times minus 25, it becomes 50. 4 times 1, 4. 4 plus 6 plus 20. Therefore, 24 and 25 will be 49 minus 15 over 4. Therefore, it will be minus 1 over 4. Therefore, coordinate of the vertex will be x, f of x is equals to what and what? The value of x is minus 5 over 2. Therefore, minus 5 over 2 and minus 1 over 4. So we already talked about range depend on the coefficient of a. That means the first coordinate is 1. Therefore, it is greater than 0. And its y coordinate of the vertex is y is equals to minus 1 over 4. And we have a general formula that says that if a is greater than 0, then range will be y greater than or equals to f of minus b over 2a. And if a is less than 0, range will be y less than or equals to f of minus b over 2a. In our case, the value of a is, you have to know, 1. Therefore, it is greater than 0. So, therefore, our range will be range is equals to y greater than or equals to f of minus b over 2. Have already get minus 1 over 4. Therefore, minus 1 over 4 will be our range. And its domain is simple, real number. Why we say real number? Because for any polynomial function, its domain is always real number. So let's take example 2. F of x is equals to minus x squared plus 4x. Therefore, to find the vertex, x is equals to minus b over 2a. The value of negative of the value of b is 4 over 2 times the value of a is minus 1. Therefore, minus 4 over minus 2. This is equals to 2. Therefore, f of minus b over 2a is equals to f of what? 2. So the value of the given equation is f of x is equals to minus x squared plus 4x, and we already get x is equals to minus b over 2a is 2. Therefore, f of minus b over 2a is equals to f of minus b over 2a is already found, 2. Therefore, when you insert 2 on the first equation, negative of 2 the whole square plus 4 times of 2. Therefore, this is minus 4 plus 8. 8 minus 4 will be equals to 4. Therefore, coordinate of the vertex will be what and what? 2 and 4. And the value of a is less than 0. So we have equation, if a is less than 0, range will be y less than or equals to f of minus b over 2. And the value of f of minus b over 2 is already found. What? It is. Therefore, range will be y less than or equals to 4. So the third types of equation, for the fourth type of equation now we are going to talk is about cubic function. Cubic function or third degree. It has a general formula of f of x is equals to ax cubed plus bx squared plus cx plus d. Therefore, its domain is x is an element of real number. Why I said it is an? Because for any polynomial function, domain will be always real number, and its range depend on whether the highest degree is odd or even. Let n be the highest degree. Therefore, if n is an odd number, that means 1, 3, 5 up to infinity, then x will be an element of domain real number and y will be an element of real number. And if n is or even number, 0, 2, 4 up to infinity, this is even, domain will be an element of real number because it's a polynomial equation, and range will may not be real number, rather it become other than real number. We will talk some examples. For example, f of x is equals to 3x plus 5. As you know, its domain is simple. X is an element of real number because for any polynomial equation, domain is always real number. But a range y or range depend on n. That means n is whether the highest degree is odd or even. In our case, from x raised to 1 and x raised to 0, the highest degree is 1. Therefore, 1 is, n is odd. If it is odd, range will be x, y, an element of real number. We can take the second example. Example 2. F of x is equals to 3x squared minus 4x raised to 4 minus 2x minus 5x raised to 7. When we take this equation, first we have to rearrange. We have to bring the highest degree to the first. From 2, from 4, from 1, from 7, the highest degree is 7. Therefore, f of x can be rearranged like minus 5x raised to 7 minus 4x raised to 4 plus 3x squared minus 2x. Therefore, our n or highest degree will be 7. 7 is odd. If it is odd, range will be y, an element of real number. Let's say this third example. Example 3. F of x is equals to 2 minus x squared minus x raised to 8. Therefore, this can be rearranged like minus x raised to 8 minus x squared minus x plus 2, because the highest degree is 8. We brought to the first, then the highest degree next to 8 is 2, next to 2 is 1, next to 0. Therefore, this is the value of the highest degree is even. If it is even, y or range is definitely not real number, rather than real number. We will talk about it, no problem. So we have already finished our discussion about this equation, and let's do some exercise. So we will do some summary exercise. So the first equation is f of x is equals to 5x minus 2. The first equation. X or its domain is x, an element of real number. Why I said x is an element of real number? Because for any polynomial equation, domain will be always an element of real number. Range depend on the value of n. N means the highest degree, whether our highest degree is odd or even. In our case, from x raised to 1 and to x raised to 0, the highest degree is 1. Therefore, 1 is odd. If n is 1 odd, its range will be definitely y, an element of real number. Second example. 2. F of x is equals to 3x plus 5 over 5x minus 4. When general formula, let's write general. Whenever you are given general formula, f of x is equals to ax plus b over cx plus d. Domain will be always x, an element of real number, different from when cx plus d equals to 0. So whenever we are given over, the numerator must be always different from 0. Therefore, cx plus d must be always different from 0. Therefore, cx, when we brought d to the right, it becomes negative 0 over c over c. Therefore, x will be different from minus d over c. Therefore, domain will be x, an element of real number, different from minus d over c. Why we say minus d? When you insert minus d over c, for example, f of x is equals to ax plus b over c times, in terms of ax, let's insert minus d over c plus d. Therefore, c will be cancelled by c, and minus d plus d is 0. Therefore, ax plus b over 0. And we know that number divided by 0 will be always real number, and 0 divided by a number will be always 0. You have to take this seriously. So our equation is, the second example is f of x is equals to 3x plus 5 over 5x minus 4. Therefore, it is domain will be x, an element of real number, different from when 5x minus 4 equals to 0, or its denominator must be different from 0. Therefore, 5x minus 4 must be different from 0. Therefore, 5x must be different from 4 over 5 over 5. Therefore, the value of x must be different from minus 4 over 5. Therefore, domain will be x, an element of real number, different from 4 over 5. Therefore, to find range, we will rearrange f of x in terms of y. Therefore, in terms of f of x, our equation is 3x plus 5 over 5x minus 4. So we will change this f of x in terms of y. Y is equals to 3x plus 5 over 5x minus 4. Therefore, we will make a crisscross. Y times 5x minus 4 is equals to 3x plus 5. Therefore, this y will be distributed. Therefore, y times 5x will be 5xy minus 4y is equals to 3x plus 5. We will collect x in the one direction and y in another direction. Therefore, we will go 3x to the right, to the left, and minus 4 over 5 to the right. Therefore, 5xy minus 3x will be, when this negative go to the right, it becomes positive, 4y plus 5. When we take common x, when this number divided by this 5, y will be left. When this negative 3x divided by x, minus 3 will be left. Therefore, 4y plus 5 over 5y minus 3 over 5y minus 3. Therefore, the value of x will be 4y plus 5 over 5y minus 3. Therefore, range will be y, an element of real number, different from what? when this must be always different from 0. Therefore 5y minus 3 must be different from 0. Therefore 5y must be different from 3 over 5 over 5. Therefore the value of y must be different from 3 over 4. Therefore range is equals to y, an element of real number different from 3 over 5. Therefore this is our range, and the first is our domain. So our third example will be third. F of x is equals to a square root of 4x minus 5. Therefore for f of x to have a real 0, real 0, not 0. It means real value. The value of radicand. Radicand means, I will write the expression under the square root, or this equation, this 4x minus 5 must be positive or equals to 0. Therefore our equation is f of x is equals to square root of 4x minus 5. So 4x minus 5 must be greater than or equals to 0, because to get what types of value? A real value. Therefore 4x minus 5 greater than or equal to 0. When we brought this to the right, it becomes 4x must be greater than 5 over 4 over 4. Therefore the value of x is greater than 5 over 4. This is what we call domain. And to find its range, we will insert what is the minimum value of its domain? X is 5 over 4. Therefore our equation is f of x is equal to square root of 4x minus 5. Therefore square root of 4 times 5 over 4 minus 5. Therefore 4 will be cancelled by 4. This is square root of 5 minus 5. This is equals to 0. So let's take a number greater than 5 over 4 over 25 times 25. This will be 1.25. You can check using a calculator what is the value of 5 divided by 4. It becomes 1.24. Let's take 2. F of x is equals to square root of 4 times 2 minus 5. Therefore square root of 4 times 2 is 8 minus 5 is root 3. This means positive number. F of x is equal, let's take greater than 2, 4 times 3 minus 5. Square root of 12 minus 5. This is equal to square root of 7. This number is approx 2 and this number is approx 1. Therefore its range will be y greater than or equals to 0. The least value of y will be, we have already done, 0. And our fourth example is f of x is equals to the square root of x square minus 4. Therefore for f of x to have a real value, the value of radicand means expression under the square root, must be greater than or equals to 0. Therefore x square minus 4 must be greater than or equals to 0. When we brought this to the right, x square greater than or equals to 4 under the square root, under the square. Therefore absolute value of x will be greater than or equals to. And we have a general formula that we will talk in the third or the fourth lecture. That means about absolute value. Absolute value of ax greater than or equals to a will be x less than minus a, or x greater than or equals to a. Therefore absolute the value of its domain will be x less than or equals to minus 2, no, less than, or x greater than or equals to 2. And to find range, we will insert we already got our domain x less than minus 2 or x greater than or equals to 2. Therefore, our equation is f of x is equals to square root of x squared minus 2. The least value will be, let's take any number less than minus 2, x minus 3, and let's take any number greater than 2, x less x 3. Therefore, f of x will be square root 2. When negative 3 is brought, it becomes 9 minus 4. This is equals to square root of what? 5. F of x, let's take 3. When we insert 3 square minus 4 will be what? Square root of 5. Let's take the least value 2. When x is 2, f of x will be square root of 2 the whole square minus 4. Okay? 0. Therefore, from root 5, the least value of 0. Therefore, it is increasing function. So, its range will be y greater than or equals to 0. And our fifth example is, example 5 will be f of x is equals to square root of 4 minus x squared. We know that for f of x to have a real value, the radicand must be greater than or equals to 0. When you say radicand, expression under the square root, that means 4 minus x squared must be greater than or equals to 0. When we brought this to the right, 4 greater than or equals, this is negative. When it's brought to the right, it becomes positive, x squared. So when we reverse, 4 minus x squared becomes x squared less than or equals to 4. Therefore, under the square root, x will be absolute value of x less than or equals to 2. We know that general formula of absolute value, if absolute value of x is less than or equals to a, its value become minus a less than or equals to x is less than or equals. So, domain will be negative 2 is less than or equals to x is less than or equals to 2. Therefore, to find range, we will insert minus 2 less than or equals to x is less than minus 2, minus 1, 0, 1, 2. Therefore, when x is negative 2, the value of y will be y is equal to square root of 4 minus 2 the whole square. It becomes square root of 4 minus 2 square. It becomes 4. Therefore, 0. When x is equal to minus 1, y is equal to square root of 4 minus 1 the whole square will be square root of 4 minus 1. It becomes root 3. When x is equal to 0, y is equal to square root of 4 minus 0 the whole square. It becomes 2. And when x is equal to 1, y is equal to square root of 4 minus 1 the whole square. It becomes what? Root 3. And when x is equal to 2, y is equal to square root of 4 minus will be f of x is equals to 0 when x is either negative 2 or 2. Therefore, and highest value will be when x is equals to 0, y is equals to 2. Therefore, its range will be 0, y is equals to from 0 up to 2. Example, our last example will be example 6. Example 6 is given by y is equals to square root of x squared plus 5x plus 6. And we know something. For f of x to have a real value, the radicand means expression under the square root must be greater than or equals to 0, and our radicand is this x squared plus 5x plus 6. Therefore, x squared plus 5x plus 6 must be greater than or equals to 0. Therefore, this equation can be solved. This inequality quadratic equation can be solved. When you add, it will give b. This is the value of A 1, this is the value of B, and this is the value of C. And B times Q will give A times C. The value of B is 5, and the value of A times C, A is 1 and C is 6. Therefore 1 times 6 is 6. What are the two numbers? When you add, it will give 5, and when you multiply, it will give 6, 23. Therefore x square plus 2x plus 3x plus 6 greater than or equals to 0. We don't add any number. When you add to x plus 3x, it will give 5x. Therefore the common between x square plus x square and 2x will be x. When this number divided by x, x will be left, and when 2x divided by x, 2 will be left. Therefore common of 3x plus 6 will be 3, and when 3x divided by 3, it becomes x will be left, and when 6 divided by 3, 2 will be left. Therefore common will be x plus 2, x plus, therefore x plus 2 common. When this number divided by x plus 2, x will be left. When this number divided by 2, 3 will be left, 0. Therefore what number will make this equation 0? Therefore x plus 2 equals to 0. X is equals to, when it become negative 2, this number will be 0. When do x plus 3 become 0? When x is equals to negative 3. Therefore from negative 3 and minus 2, which number is less? Negative 3. Therefore we will draw a vertical line, minus 3, this minus 2, and we have equation x plus 2 and x plus 3. Therefore when do x plus 2 become 0? When the value of x is negative 2, and any number less than negative 2, let's take minus 2.5. When we insert minus 2.5 plus 2, it becomes minus 0.5. Therefore it becomes negative. When you insert a number less than minus 3, minus 4 plus 2, negative. Therefore when insert any number greater than 2, for example 3 plus 5 is 5. Therefore this becomes positive. When do x plus 3 become negative? Under negative 3. Any number greater than negative 3, let's take 2. When insert 2, it becomes positive, or negative 2.5 plus 3, it becomes 0.5. It is positive. And when you insert 5, it becomes positive. When you insert 3 is greater than 2. 3 plus 3 is 6, positive number. So we are asked to find their multiplication. Therefore negative, this is negative, because less than negative you can take minus 4. Minus 4 plus 3 is minus 1, it becomes negative. Negative times negative, positive. Number times 0, 0. Negative times positive, negative. Number multiplied by 0, it becomes 0. Positive times positive, 0. Therefore greater than or equal to 0 means positive number. When do it become positive number? This is given greater than or equals to when x is less than or equals to minus 3. When it becomes minus 3, we are given 0, and we are asked greater than or equals to 0, or when the value of y is, when the value of x is greater than or equals to when 2. Therefore its domain will be x less than minus 3 and x greater than 2. Therefore to find the range, we will take the smallest value. X is equals to minus 3 and x is equals to 2. When you insert negative 2 on the first equation, you can change. When you insert negative 2 in the first equation, our equation is x square plus 5x plus 6 greater than or equals to 2. Therefore when you insert negative 3, our equation y is square root of x square plus 5x plus 6. When you insert negative 3, square root of negative 3 the whole square plus 5 times negative 3 plus 6. Therefore this is equals to negative 3 the whole square, 9. 5 times minus 3, it become minus 15 plus 6. 6 plus 9 is square root of 50 minus 50. It become what? 0. Therefore when the value of x is greater than or equal to 2, let's take 2. 2x is equals to 2, y is equals to square root of 2 square plus 5 times 2 plus 6. Therefore, square root of 2 square is 4 plus 5 times 2 is 5 times 2 is, what is 5 times 2 is 10 plus 6. Therefore, square root of 4 plus 6 will be 20, become 20. Therefore, its domain will be, its range will be, the least value is 0. Therefore, y greater than or equals to is our least exponential function, or simply exponential. Exponential means any type of equation that can be written in the form of a raised to x is equals to b, where a is called base and x is called exponent and b is called what? Product. For example, 3 square is equals to 9, where 3 is called base, 2 is called exponent, and 9 is called product. 4 square is equals to 16, where 4 is called base, 2 is called exponent, and 16 is called product. 2 cube is equals to 8, where 2 is called what? Base, and 3 is called exponent, and 8 is called product. So there are 6 main property of exponent. And the first one is when a raised to x times a raised to y is given, it is always a raised to x plus 5 for the two functions. For example, 3 square times 3 raised to 4, we will see the base are the same and exponent are different. Therefore, in our example, the base are the same and exponent are different. Therefore, it becomes 3 raised to 2 plus 4. Therefore, this is equals to 3 raised to 6. And the second example is when you are given x raised to square times x raised to 5, since the base are the same and exponent are different from the property 1, x raised to 2 plus 5. Therefore, our answer will be x raised to what? 7. If we are given a lot of function, for example, a raised to x times a raised to y times a raised to z up to a raised to n, its answer will be a raised to x plus y plus z up to n. For example, 3 square times 3 raised to 4 times 3 raised to 6 will be from property this. It becomes 3 raised to 2 plus 4 plus 6. This is equals to 3 raised to 2 plus 4 is 6. 6 plus 6 is 12. Example 2 is x raised to x square times x raised to 4 times x raised to 6 times x raised to 9 will be, since the base are the same from property first, when the base are the same, and if you are given up to n, in our case they are 4. 1, 2, 3, 4. Therefore, it becomes x raised to 2 plus 4 plus 6 plus 9. Therefore, this is equals to x raised to 2 plus 4 is 6. 6 plus 6 is 12. 12 plus 9 is 21. And if you are given x raised to 2y plus 4x plus 7x, this can also be written as x raised to 2y times x raised to 4x times x raised to 7x. Why I said that? We know that a raised to x times a raised to y is a raised to x plus y, and when we change the reverse, a raised to x plus y is equals to a raised to x times a raised to y. You have to take this seriously. Therefore, we are taking the reverse. Therefore, our answer will be, this can be written as this. Therefore, we are right whenever we are given x raised to 2y plus 4x plus 7x, we can write, or simply general formula whenever we are given x raised to a plus b plus c up to n. This can be also written as x raised to a times x raised to b times x raised to c up to x raised to n. Example 2 will be 3 raised to x plus y plus z plus a can also be written as 3 raised to x times 3 raised to y times 3 raised to z times 3 raised to a. From property what? Property this. So rule 2 will be, when you are given a raised to x times a b raised to x, if the base are different and if the exponent are the same, then we will multiply its base, ab raised to x. For example, 3 square times 4 square. When we see the base are different, 3 is different from 4 and 2 is equals to 2, the same. Therefore, from property rule 2, we know when the base are different and exponent are the same, we will multiply its base. Therefore, it becomes 3 times 4 the whole square. It becomes 12 square. 12 square is equals to 144. And example 2 is, when we are given more than 2 factor, for example, this is for 2 variable. When we are given 3 or 4, general formula a raised to x times b raised to x times c raised to x up to n raised to x, it becomes, simply multiply its base, a times b times c up to n raised to x. For example, 3 square times 4 square times 9 square times 16 square will be, simply, since the exponent are the same, we will multiply their base. 3 times 4 times 9 times 16 raised to 12 will be our final answer. And rule second b will be, when you are given a raised to a b c d raised to x is equals to a raised to x times b raised to x times c raised to x times d raised to x. For example, 3 times 4 times 5 the whole square can be written as 3 square times 4 square times 5 square. From property what? When you are given if the bases are multiply and raised to x, then our answer will be like this. For example 3 will be x times y times z raised to 4. This is z. Therefore, this can also be written as x raised to 4 times y raised to 4 times z raised to 4. From property what? This property. And rule 3 will be, when a raised to x over a raised to y are given, and if the bases are the same and its exponent are different and its over division, its formula will be a raised to x minus y. And we have to make some generalization on this equation. X raised x times y times z up to n raised to x is equals to x raised to x times y raised to x times z raised to x up to n raised to x. This is our rule what? Rule third. For example, 3 square over 3 raised to 4 since the bases are the same and its exponent are different. And its over division we use 3 2 minus 4. This is equal to 3 raised to minus 2. This is also can be written as 1 over 3 square. We will talk about rule 6. Therefore our equation, our rule says that a raised to x over a raised to y will be a raised to x minus y, and x raised to a over x raised to 5b minus 3 also can be written as, since the base are the same and exponent are different, it can be written as x raised to a minus, we have to make always bracket whenever division are multi or more than 2 variable. Since 5b and 3 are more than 1, we have to always make bracket 5b minus 3. Therefore x raised to a, when negative multiply by minus 5 it become minus 5b, when negative multiply by minus 3 it become positive 3. Therefore this is our final answer. So our fourth rule will be if you are given a raised to x over b raised to x, and if the bases are, this is base different and exponent are the same, we can make a over b raised to x. For example, 3 square over 4 square can be written as 3 over 4 the whole square. From property what? This property. X square over x raised to y raised to 2 also can be written as x over y the whole square. C square over d square also can be written as c over d the whole square. And rule 5 stated that a raised to x raised to y can be written as a raised to x y. For example, 3 square raised to 2 can be written as 3 raised to 2 times 2. This is equals to 3 raised to 4. X raised to y raised to z can be written as x raised to y times z. This is equals to x y z. And a raised to x raised to y raised to z up to n can also be written as a raised to x times y times z up to n. For example, 3 raised to 4 raised to 1 over 3 raised to 1 over 6 also can be written as 3 raised to 2 times 4 times 1 over 3 times 1 over 6. From property what? This property 5. Therefore this is equal to 3 raised to 2 times 4 is 8 over 3 times 6 is 80. So by 2 4 by 2 9. Therefore our answer will be 3 raised to 4 over 9. And our final rule will be rule 6 will be, when you are given a raised to negative x, this can also be written as 1 over x. For example, 3 minus 2 can be written as 1 over 3 square. 3 square is equals to 9. 1 over 9. Or 1 over a raised to x is equals to a raised to minus x. For example, 1 over 10 can be written as 10 raised to minus 1. How? It is 1 over 10 raised to 1. We know that 1 over a raised to x is equals to what? A raised to minus x. The value of its base is 10 and its exponent is 1. Therefore, base, we have to write base first, 10. Exponent is x. X is 1. When we brought to the side, it becomes minus 1. Therefore, this is our final answer.